In today's video, we'll be discussing how to solve augmented matrices using Gaussian elimination. An augmented matrix is a matrix derived from a system of linear equations. The layout is really simple. Put the coefficients for x, y, and z per equation in one line. Then a semicolon or a line sometimes acts as an equal sign to put the constants on the other side. Here's a basic example. Let's say we have a system of 3 equations and we want to convert this into an augmented matrix. We just take the coefficients for the respective equation. Let's say for the first one, we can see that the coefficient for x is 1, the coefficient for y is 3, the coefficient of z is 4, and the constant is 7. And so that's how we lay it out. It's important to keep the organization as the first column of x, the second column of y, and the third column of z, and the last one as constant. As long as all the coefficients are for the same term in one column, it should be okay. Note that if there's no x, y, or z variable, that means the coefficient in front of that variable is 0. So just put a 0 for that slot. Now let's look more into what Gaussian elimination is. It produces a matrix in row echelon form. And from there you can use back substitution. Let's look at an example. So let's use the matrix we were working with before, and let's label our equations. If you're not sure how to do this, please refer to my previous video about an introduction to matrices. Number 1 will be equation number 1, number 2 will be equation number 2, and number 3 will be equation number 3. Remember, you always want to choose equation 1 as the one where the coefficient of x is 1. That's highly preferred. So let's look at our goal for doing our row operations for a second one. As you can see, what we did is we got rid of x in the second and third equation. And how we did that is by modifying equation 1 and adding it to 2, for instance, in the second line, and modifying equation 1 and adding equation 3 for the third line. As you can see, when we multiplied -2 by 1 and then added 2, the x's canceled out, and then we continue the operation. If you're not trying to do this, I also recommend checking out my previous video. And then we're just going to continue the steps. Let's say we want to isolate z in the third equation, and we get the row echelon form. As you can see, there's ones across the diagonals, and below the ones, there are zeros, which is row echelon form. Then we can multiply by 1/5 for the difference of 1 minus 2, and that actually makes z have a coefficient of 1, aka it isolates z. If you didn't do 1 multiplied by 1/5, you can do that in 2 different steps. But without multiplying 1/5, it would have been 5z is equivalent to -10. So as we can see, is this row echelon form? Yes, it is. So we can see that z is equivalent to -2 from the last row. From doing back substitution, we can just plug in z for the second equation, which gives us y equals -10. And doing the same thing, we get x equals 45. So the answer is 45, -10, -2. As you can see, for the variables that didn't have a coefficient, we just put a 0. A really helpful tip is to make sure to use each row operation to try to eliminate variables so you can have 0 as a coefficient and get to row echelon form. I hope this video helped. Comment down below any other math topics from your review. Thank you.